All right, welcome everybody. It's nice to see all these faces out here in midsummer. So welcome to the meeting tonight. Let's go ahead and get to it. We actually have a pretty full evening. We have 6 speakers scheduled from the club here tonight. So we have a pretty full time. Anyway, let me go ahead and get started here. I have to kind of get myself. I just drove in from Albuquerque a little while ago, so I'm kind of still getting my head back in the game here. So anyway, as always, welcome to everybody in the room. For those that are out on Zoom as well, we welcome the people on Zoom. As always, if you're going to speak during the meeting, wait till we give you a microphone. So if you want to ask a question, make a comment, whatever, because if you don't speak into one of these mics, then the people out that are joining on Zoom, and usually we have anywhere from 10 to 20 on Zoom, and they can't hear anything. So we always wait for them and use the mics so they can hear. Anyway, if you haven't already done so, it's a good time to put your cell phones on vibrate. So I'm going to do mine right now in front of you all. So mine is now on silent, so we don't get any surprises during the meeting. And do we have any visitors tonight? And if so, if you'd like to introduce yourselves, we'd like to meet you. But if you're kind of bashful, we're not going to force you to do it. But if we have any visitors, you can put your hand up and we'll go quick. So we do have a couple. So let's go ahead, and Andrea, we got one over here and one over here, I think. So
I guess I'm first. I'm Ken Ekstrom, and thanks to John Janzen, I found out about this.
People here. Let's see. Here's the new kid in town. If you're not aware, we have an observatory here. Most of you are aware of that. Just a 5-minute walk over into the park there. We have a observatory over there that is open to the public every Friday and Saturday night from dusk till 9:30. And up in Fountain Hills now, they've actually been building for well over a year now, their own observatory up there, along with a whole science center. I went up there. It says last month on the slide, but I was going to do this ago. I went up there, and they did sort of a test run. Ted Blank is the gentleman that sort of heads that up there. And he invited like 30 guests in. It was a very limited crowd, and just sort of a test run to see how everything worked and their procedures and how to form lines and things like that. It was actually a great time. That's their dome up there. This little, let me bring up a laser pointer here so I can point out some things. Right here, this little gate area you see right here, that's almost 8 feet tall. So that'll give you a scale of this thing. So the dome is actually quite large and quite tall. Anyway, inside of this dome is a plane wave that looks like that. It is an amazing piece of equipment they've got up there. So it's a 27-inch plane wave telescope. Once again, you can see there are some people right in here, and that'll give you a sense of the scale of the size of that telescope. So look right through the plane wave that way. The snorkel itself is interesting. It's just some, basically steel framing to hold things, and it's 2 refractor telescopes just butted up one against the other, and that forms the snorkel to look through the telescope. So really there's a reflector there and 2 refractors as well. In addition to this big 27-inch, they have some other telescopes as well. I'll show you those in just a second. This was actually their first light picture. So as you can see, it takes pretty good pictures. And so they decided to use their first light picture as the background for their control console, is what they're using there. In addition to that, they actually went out to Celestron and begged and borrowed and whatever from Celestron. And so Celestron sent them multiple 14-inch Edge HD telescopes. And in addition to that, you don't see it in the picture here, they ZWO sent them an S30 Pro. And then they've got that set up with a big screen. So whatever you can, whatever the S30 Pro is looking at is projected out on a large screen as well. So it's actually a wonderful setup they have up there. Very nice. Here's the close-up of the Celestron. I got looking at this picture, I don't know, a week or 2 ago, and I realized that telescope is really confused right now because it's flipped upside down, I realized. So, yeah, I think this one needs a reset, this telescope. But anyway, that's kind of what the 14-inch Edge HD Celestrons look like. They're very nice setups. I operated one for a little while up there. It's actually a wonderful device. So anyway, that's what's happening up in Fountain Hills. I'm not sure the exact opening date, if it actually occurred or not. I was going to try to check with Ted, but given my travel schedule the last couple of weeks, I kind of lost it. Question in the back. Oh, I can repeat it. Oh, she's got it right there. Good.
So that facility is going to be open to the public eventually?
Yes.
And then with the 27-inch, that snorkel, did they do that so they wouldn't have the danger of people up on a ladder?
Correct.
And how much light loss is involved in?
I have no idea. You need to ask Ted Blank. That's all his purview, not mine. So, but I have no idea.
Thank you.
It's a wonderfully clear image. I can tell you that. If there's light loss, and there might well be, I didn't notice it when I looked through it. It's actually quite lovely. Anyway, so I just thought I'd share that since they're kind of our neighbor to the north, and we do a lot of things with Fountain Hills over the course of the year. We help them with their Dark Sky Festival. Ted's a member here, and Ted's often here, and Ted works at Grotto as well, so it's pretty fun. I've actually volunteered to work up there one night a month, so I'm kind of excited about that. So, Alice, you're on. Run. So, yeah. All that work for 3 slides, because that's all she's got.
I'm excited about those 3 slides. All right, my name is
That was
Alice,
kinda
and
weird.
I am the events coordinator, which basically means I head up the outreach program. And people often ask me, what is the benefit of becoming a member of our club? And I always say, well, you're able to give back by joining our outreach program. And we have 2 ways actually of giving back. First one here is just down the sidewalk here at Greco. So Greco is open every Friday, Saturday night from sundown until 9:30, obviously weather permitting. You can help with guests, with operating the telescope. If it's something that you are interested in doing and you are a member, down at the very bottom there, the Greco at evaconline.org, talk to the manager, and that is Claude Hayes, and he will get back to you. Just send him an email, let him know you're interested, what you're interested in doing, what kind of background you have, and yeah, you can volunteer up there and share your love of astronomy that way. Or this is my gig, giving back to the community through outreach events. So what does that entail? I have a schedule. Right now it's pretty slim. It is summertime, it's hot, it gets dark later. So really the only second Friday star party we have in the summertime is our second Friday public star party that is complementing Greco. But typically, I usually have about 2 star parties a week during the season, which will start up, just like Steve said, about into September, into October. You can pick what star parties that fit your schedule. And I have 2 ways you can volunteer. First is you can bring a telescope, you can bring binoculars, and you can share whatever object in the sky that fancies you, that is interesting, know some facts about that object, and you just share it with guests that come up to it. Next, I can always use what I call walkers helpers, and these are people who help me with the guests. So sometimes there's a long line at the telescope, and you can entertain the guests and educate them, pointing out constellations or telling them facts about what the astronomer has in the eyepiece at that time. Also, it's great with the younger guests to remind them of telescope etiquette, such as no food or drink by the telescope, no running by the telescope, that kind of thing. So 2 ways you can volunteer: bring a telescope or binoculars, or be a walker helper. You can choose what parties to attend to help out with. Usually they're about an hour, hour and a half, sometimes 2 hours. The big thing is you need to be signed up for this EVAC online free list outreach. The very, very bottom one right there says to get on the volunteer mailing list. Definitely sign up for that. I do all of my communications through that email, cancellations, rescheduling. Sometimes I might have to add something, and so I'll ask volunteers if they're able to accommodate somebody with a star party that wants, say, a astronomy booth and the telescope viewing. So very important that you sign up for that. So, like I said, our star parties have been very limited, but this month we were able to have it. So there are my volunteers right there, and you can see in the background that there's Grotto. I want to say thank you to all of our volunteers in that picture. It was extremely hot, it was humid, and we were glistening under the stars that night. But we had, I want to say 162 guests at Grotto, which means we had that same amount. Now, that doesn't sound like much, but we only had about an hour and a half of viewing. So that's a lot of people in an hour and a half. So thank you to my volunteers. I appreciate it. Thank you actually to all of my volunteers. I say my volunteers because you guys are near and dear to me, but I should say our club volunteers. It is you who make this outreach possible. If I did not have volunteers, I would not have outreach. So I appreciate your time, your talent, as well as all of our Star Party schools, HOAs, libraries, the guests as well. So a huge thank you to that. Oh, here we go. Cosmic Conundrums. All right. You're up now, Steve.
All right, we had done this, once again, I said this earlier, but we had done this back in either January or February, and it was very popular. I said, would anybody want to do this again? And every hand went up. So anyway, so you have pencils and you have answer sheets there on all the chairs. And at the end of the evening, just put your answer sheet and your pencil back on your chair, and we'll have some volunteers come up and collect all the answer sheets and basically trash those, but then we keep the pencils, of course, for the next time around. So just like I said, leave stuff on your chair when the evening is over. Anyway, if you're ready to go, we'll go ahead and do this. It's 32 questions is what it is. And the one thing that I was asked from the last time was make the questions simpler. So, so apparently you folks aren't very educated, and I have to, no, I'm kidding. So anyway, dumb it down. No, anyway. So like the first question is, how many letters are in the word Earth? No, I'm kidding. No. So anyway, it's not quite that bad, but anyway, it will be a little bit simpler this time around. So what'll happen is I'll put the questions up there. You'll see the options, and you'll basically choose A, B, C, or D and put it on your answer sheets, what you'll do. And anyway, let's go ahead and get to it here. So first question, on average, which planet is closest to the Earth? Saturn, Venus, Mars, or Mercury? So I'll give you a second to think about that, and then I'll reveal the answer, and you can mark it as correct or incorrect. By the way, this will also be sort of form as an entry exam to determine whether or not you're allowed to remain in the club. So anything less than 10, we're going to have to ask you to leave. And all right. So the answer is D. It's actually Mercury. Occasionally Venus is closer, but on average, Mercury tends to be closer to the Earth than does Venus. All right. Question number 2. What is the name of our second nearest star? So is it Proxima Centauri? Is it Polaris? Is it Sirius? Or is it the Sun? So what's the name of our second nearest star? And no Googling. So anyway, it's A. It's actually Proxima Centauri. So that's the correct answer there. Question number 3. Which planet is the smallest in the solar system? Kind of a trick question here. So Mercury, Mars, Venus, or Pluto? So read the question carefully. What's the smallest planet? Because Mercury is what? It's a dwarf planet. So it's a little bit wrong there. All right. Question number 4. What causes seasons on Earth? Is it our orbital motion? Is it our axial tilt? Is it gravity, or is it our moon? So what's the main reason we have seasons on Earth? You all thought about it? You had a minute? All right. So the answer is B, axial tilt. All right. Question 5. What is the sun's energy source? Is it burning hydrogen? Is it nuclear fusion? Is it electromagnetism? Or is it chemical reactions going on inside the sun? So which is the reason that the sun has so much energy? And you probably, hopefully, will got this. It's B, which is nuclear fusion. To this day, I mean, this movie's got to be like 30, 40 years old, but all I can hear is Chekhov in one of those old Star Trek movies looking for the nuclear vessels, if you remember that from the movie. So anyway, the nuclear fusion. Anyway, question 6. Which astronomer developed the laws of planetary motion? Was it Faraday, Galileo, Einstein, or Kepler? And give you a second to think, and the answer here is going to be Kepler. The correct answer. All right, question 7. What is a meteor? It's a space rock hitting the Earth's surface. It's a space rock burning up in the atmosphere. It's an asteroid passing Earth, or it's a comet passing Earth. So what is a meteor? And the answer is going to be B. It's a rock that burns up in the atmosphere. All right, question 8. What is Earth's atmosphere mainly composed of? Is it oxygen, carbon dioxide, nitrogen, or hydrogen? If you are a scuba diver, you probably would know this one pretty quick as well. So. And the answer is going to be C, nitrogen. Get too much of that in the body and you get the bends. That's why divers have to be careful not to take on too much nitrogen. What is the main component of Saturn's rings? Is it hydrogen gas? Is it ice and rock? Is it plasma, or is it dust? What's the main component of Saturn's rings? And the answer, of course, is going to be ice and rock. So. All right, question 10. Which planet has the highest surface temperature? Is it Mercury? Is it Jupiter? Is it Saturn or Venus? Which one has the highest surface temperature? And the answer is Venus. Due to all the carbon dioxide and other methane, other chemicals in there, runaway greenhouse effect. All right, what is the main component of Uranus's rings? Is it hydrogen gas, ice and rock, plasma, or dust? And the answer is going to be dust. So the dust is not very reflective, so that's why we don't see the rings around Uranus. Where it was ice and rock, it's highly reflective. We see Saturn's rings. All right, question 12. Which planet has blue coloration due to methane in its atmosphere? Which planet has blue coloration due to methane in its atmosphere? Is it Mars, Venus, Neptune, or Mercury? And the answer is going to be C, Neptune. Hey, question 13. What is meant by redshift? It's light turning red from heat. It's light waves being compressed by objects approaching you. Light waves being stretched by objects receding away from you. Or is it a star transitioning from the main sequence to a red giant? So what does a redshift mean? And the answer is C, light waves being stretched out by objects receding or moving away from you is what that is. Okay, 14. Which type of binary star system is identified by detecting shifts in absorption lines rather than by directly observing two separate stars? So is that a visual binary? Is that an eclipsing binary? Is that an astrometric binary? Or is that a spectroscopic binary? I had a chance to think. And the answer is going to be D. It's a spectroscopic binary is what that is. Oh, 15. This is halfway point. So which law states that a galaxy's redshift is proportional to its distance? Is that Newton's laws, Kepler's laws, Hubble's law, or Einstein's law? Which one is that? And if you guessed C, or you knew it was C, you got it correct. Go to IFL. Okay. Okay. All right. Let's see. Number 16 here. Question 16. What type of galaxy is the Milky Way? Are we an elliptical galaxy? Are we a barred spiral galaxy? Are we an irregular galaxy? Are we just a plain spiral galaxy? And survey says we are a barred spiral. That's what we are. Yeah. All right, question 17. What is an event horizon? Is it the boundary around a black hole? Or is it a boundary around a black hole? Is it the edge of a galaxy? Is it the edge of our atmosphere or some other planet's atmosphere? Or is it the boundary between the solar wind and interstellar space? So what is an event horizon? And the answer is going to be A. It's the boundary around a black hole. All right, 18. What is the source of cosmic microwave background radiation? Is it radiation from stars? Is it the afterglow from the Big Bang? Is it the solar wind is the source? Or is it the heat from Earth that creates the source of cosmic microwave background radiation? If you chose, it's the afterglow of the Big Bang, you're all set, you're ready to go. All right, 19. What does parallax measure? Does it measure temperature? Does it measure the brightness of an object like a star? Does it measure mass like a star's mass? Or does it measure distance? And the answer is going to be distance, is what it's going to be. Question 20. What is the Chandrasekhar limit? Is it the maximum star diameter? Basically govern how big a star can be. Is it the speed of light in a vacuum? Is it the maximum galaxy diameter or maximum diameter of a galaxy if you prefer? Or is it the mass limit for white dwarfs? What do you think that is? And the answer is, what do you think about it? Is D. It's the mass limit for white dwarfs. Question 21. Which planet has the highest albedo? Is it going to be Venus, Earth, Mercury, or Mars? Which one has the highest albedo? Of course, that sort of begs the question, what's an albedo, right? So anyway, all right, and it is actually going to be Venus. So Venus, if you're not familiar with the term albedo, it's just how well something reflects light. And the atmosphere of Venus is such that chemically it's very highly reflective, so it has a very high albedo as well. So that's Venus. Okay, question 22. What is a type 1A supernova used for? Is it for measuring distances in space? Is it for measuring the mass of a star? Is it for identifying the first galaxies to form? Or is it for finding and measuring exoplanet mass? What is the type 1A supernova used for? And it is used for A, measuring distances in space. A lot of you will be familiar with the term standard candle. It's one of our primary standard candles for measuring distances. Question 23. What is dark energy thought to do in the universe? Slow down the universe's expansion, be the source of high energy gamma radiation. Is it to speed up the universe's expansion? or be the source of the cosmic microwave background radiation? What is dark energy thought to do? The answer is C. It's speeding up the universe's expansion. Although if you've been following the news lately in the last, I don't know, several months, there's now some discussion about whether there is such a thing as dark energy. We just getting the theories wrong. So we'll have to see how that works out over the next few years. Very interesting research going on in that area. Question 24. What is the Roche limit? And of course, you all know that because I lectured on that 4 years ago, and you all remember me when I lectured on that. So anyway, what is the Roche limit? Is it the maximum mass of a star before it becomes a black hole? Is it the minimum orbital distance before an object breaks apart? Is it the maximum size of a galaxy before it becomes unstable? Or is it the temperature limit of a star? What is the Roche limit? And it is answer B, the minimum orbital distance before an object will begin to break apart. It's in orbit. 25. What is gravitational lensing? Is it reflection of light, bending of light, blocking of light, or absorption of light? And the survey says it is the bending of light. Right. Number 26. What does Hubble's law describe? So star formation, universe expansion, planetary motion, or gravity? Okay. We had a question similar to this just not too long ago, and the answer is going to be B, the universe's expansion. All right, number 27. What is the last element that can be forged inside of a star before nuclear fusion ceases? Is it going to be helium, oxygen, carbon, or iron? And the answer is going to be iron. So, any of your heavier elements than that are going to be created during supernova type explosions. So anything heavier than iron. 28. What causes auroras on Earth? Is it gravity? Is it thermal energy? Is it solar wind interacting with the atmosphere? Or is it just a thing of moonlight, the way the moon happens to be shining that night? And the answer is going to be C, solar wind interacting with our Earth's atmosphere. 29. What is a brown dwarf? It's a large exoplanet. It's a failed star. It's a small dim galaxy, or it's a dead neutron star. So what is a brown dwarf? Okay, and the answer is B, it's a failed star. A star that wasn't quite large enough to ignite with fusion, so it's just hot and brown. So they call them brown dwarfs. Actually, not brown, it's bright, but it's just hot. All right, question 30. What is spectroscopy used for? Is it used for measuring gravity, for measuring the cosmic microwave background radiation? Is it for detecting sound, or is it for analyzing light? Which one of these is it? Answer is D, analyzing light. And there's just a couple of bonus questions here, simple stuff. What determines the star's lifespan? Is it its mass? Is it its color? Is it its temperature? Or is it its chemical composition? So which one of those things affects how long that star is going to survive? And the answer is going to be A, mass. The star's birth weight determines everything about that star. So birth weight is everything. And last question here. Who is the Lowell historian that has lectured at our meetings multiple times? So anyway, Is it Kevin Schindler? Is it Kevin Lagore? Is it Kevin Spacey? I thought that worked pretty well. And then Kevin Costner. Yeah, and it's actually Kevin Costner. No, I'm kidding. It's Kevin Schindler, if you remember. He's been here almost once a year for the last few years now. Very interesting guy. Anyway, all right. So we're going to find out who's the winner. Anybody get them all correct? All 32? Well, I did. Come on. No. Okay. Anybody get 31 correct? Anybody get 30 correct? Oh, I got a Gordon. Winner, chicken dinner. Gordon, come on up here. I have books. You get to pick one out. So anyway, I'll put this over here while Gordon's doing that. I'll start with, so anyway, pick the one you like, the best. All right, where was that? You were 30, right? Or were you 31? 30? 30, okay. Anybody get 29 correct? Oh, we got a couple here. So Nathan, you can pick up a book or you can give it to the young gentleman behind you. What would you prefer? Okay, then you now are the proud owner of a book back there. So, all right. I was just told we have both of them. Oh, okay. Okay, well then guess what? Nathan, you're going to get a book anyway. So anyway, hang on. Let me hand this out. All right, so we're calling this segment here from Nebulas to Know-How, your turn to present. So we had 7 people put their hands up to present. Actually, 6 of them are actually here tonight. So we'll have 6 presentations here. And the first one up is actually going to be Alice Klobe. So Alice, you want to come on up and do your thing.
Okay, hello again. So I am saying this is my Messier Stroll. So in 2024, I went to my first Messier marathon, and Gordon, being the ever supportive partner that he is, bought me this really cool book. And there we go. There you go, guys, on Zoom. And everybody else, here it is. All right. And it is called Messier Catalog Workbook. Now, I'm not a kind of person that's going to stay up all night. I'm lucky to make it till 10 o'clock at night. Now, at the Messier Marathon, I do make it to, I think this year I made it to 1 o'clock. I think it was midnight or 1 o'clock, but after that, done. So I knew I was not going to find all of these objects then. And so I told Gordon that, and he goes, hey, you know what? That's okay. You know, take a couple of months, take a year to do it. I'm like, hey, I think I'll just, do that, take my time. And so I started, as it says on the screen, June 1st, 2024 was my first object. And I have been using my SeeStars, the S50 and the S30. This workbook, I absolutely highly recommend it. Super easy to use. So let's dive into it. So I'm using the example of Messier 42. As you can see up here, oh, I wanted my little pointer finger, but I missed it. All right. So it gives you at the very top, Messier 42. And then it gives you, hey, what is it? It's a reflection emission nebula. It's in the constellation Orion. It's a 4 magnitude. And then, oh yeah, look at that. Hey, thanks, John. Wow, I learned something new every day. Yeah, all of this information right here. And then, let me get my eyes on so I can actually, oh, wow, that's even better. Then it tells you, how do I find this target? Right here. It shows it right here. And then it gives you, brief history right over here. And then, hey, what was the first observation right there? Another cool thing that I can't remember my next slide. Yeah. All right. Here's what I think is really cool is at the bottom corner. Let me go back. So in this corner right here, you can put your picture or your drawing as like John Janzen would probably do. And little plug right there. And on this particular one here, it'll give you the type of telescope that you used, what magnification, what was the moon phase, what time, what date, your first impressions, and then down here, your photograph or your drawing. So I have been going through and using, like I said, the SeeStar S50 and then the S30. And I've also been learning a lot by going through this book. So I have planned what objects I'm going to be doing when. And the S50 SeeStar, it takes more close-up pictures, and the S30 takes a more wide field of view. So I would go through, again, this lovely catalog and go, okay, well, how big is this object that I'm going to be doing? Am I going to use the S30 to do it? Am I going to use the S50? What season is it? You know, hey, is it summertime? And there are a ton of Messier objects in Scorpius and Sagittarius. Am I going to be, you know, using the whole week to try and image? What am I going to want to image when I go to the Messier Marathon? What am I going to want to image when I go to the All Arizona Star Party? So there was a lot of planning involved and having to learn the night sky. Again, what is up when? Currently, I have 6 more objects. Here's my little page up there on the screen, but I also have it in my book right here. So I need to get, hopefully skies clear out here pretty soon, but you can see that I have, oh, look, I forgot, I have my little thing here. So August, I have M30, which is in Capricornius, all right? I could do August, September. Then I have Ursa Major under the tail. Here's my notes. That's spring, summer. So I have M63, M94. That's what I really need to get done pretty soon. Here are the 3 that are going to be really difficult to do. I'm planning on maybe getting up really wicked early in the morning. I have here October early morning for M46, M47, M93. I can't pronounce this word, but it's the very tip of the ship. And it's really visible February and March, but again, like I said, I'm hoping early October, wicked early in the morning. So we'll see. Maybe I'll finish this year. Maybe it'll be next February, March. So something I don't think a lot of people know about is that we actually have a observing program with the club. I don't think you have to be a club member. You don't have to be a club member to do this. So it's on our website, evaconline.org. It's under news and resources, and it's under the observing program. And as you can see right here, it kind of gives you directions on how to get started. And then right here is the Messier program, and you just click on that. And it's going to take you to this printout. You can see I have already filled out all of my stuff right here. And then I've highlighted the 6 I need to finish. So what you would do is you would print this out and fill it out. Because I'm using a SeeStar, I haven't filled out all of it, but one of the columns is, it gives you the M number, the constellation it's in, the magnitude, then you fill out the date observed, what kind of telescope, what eyepiece, and then any notes. I have just filled out the date observed and what type of telescope that I used. And then I also have, I don't know if you guys, yeah, you can, little asterisks right here next to some of these I've already done. Those are ones I want to go back and really image. They're probably nebulas, to be quite honest, because they're gorgeous. So when you finish this, what I'll do is I'll go to our illustrious president, and I will give him my forms. Then I'll give him my book as proof. Hey, it's all filled out. And then I'll get this little plaque saying, hey, I completed my Messier Stroll and the date. And I'll probably put that on the S50 because that's what I did the most with. So if you are interested in checking this book out after the meeting, feel free to come and just page through it. But again, I highly, highly recommend it. And, I'm done. Let me go back. Any questions? Yes. Oh, it is yours. There you go.
Did you buy the printed one through Amazon or did you all print it yourself?
The pictures? The book. Oh, no, the book. Gordon, you bought that off of Amazon, didn't you? Yeah, off of Amazon.
You can also buy the PDF and print it yourself.
Oh, I did not know that. Awesome. All right. Anybody else? Questions, comments? All right. Yeah. All right. He just asked how many hours. I have no idea. I'm up to 2.5 years currently. So we'll see. It may be a 3-year stroll. Yeah. Yeah. Yeah.
When you're done, what's next?
Great question. So I think it was last year's Messier Marathon. Jeff Foreman actually won a Messier, what is it called? Thank you, Planisphere. He won it. He already had one, so he gave it to Gordon. On the back of that Planisphere are icy objects. So I'm going to go for those next. Those are icy objects. Yeah. Yeah. Caldwell. Oh, all right. All right.
I'm a beginner. What does Messier mean?
So, great question. So there was this French guy named Charles Messier. This is how I describe it, actually. And he was actually looking for comets. And he would come across these other objects that were not comets, and he would log it. Now, he gets a lot of the credit, but there were other astronomers helping him out in the search for comets as well. So there are 110 Messier objects that were not comets. And later on, when the telescopes got better, people would go back and go, oh, wow, that's a galaxy. That's a star cluster. That's a nebula. And so every year at, I think it's March. Yeah, I think it's March. We have what's called a Messier Marathon. And so all of those objects are viewable in the night sky in one night. So literally sun goes down, you start observing until the sun comes up. And we do have some of our members here that have done that. And kudos to them. I could never do it, but they're actually beautiful objects. You learn a lot about astronomy. You learn a lot about the science of astronomy. You learn a lot about the night sky. What is up when? Yeah.
I know you know this, but with your S50, you don't have to be awake. You can set up a plan.
Yes.
And,
Yes, I
and it'll
could.
do it for you.
But you know, it's like a child. I don't want to leave it alone because I don't trust it. All right. Well, thank you guys. All right.
Okay, I'm feeling much better. I have my popcorn break, so I'm a happy camper now. All right, next up we have John Janzen. So, okay.
Well, good evening. My name is John, and what do I do here? Arrows? All right, there we go. So tonight, I'm going to talk about sketching my observations, something that I've fallen in love with and I'm really excited about. And I hope from this presentation that some of you will see this as something that you would like to try, and that is, I think it's pretty simple, and I hope I can demonstrate that it is. But I really love this, this bit of artwork. And I've got some of my examples over there, and I'll be at the table later on to answer any other questions that you might have. So a little bit about myself first. I am my day job is a geographer. So I do some cartography. I work for a local suburban Indian tribe in their, it's called GIS, Geographic Information Systems. And so I work with data, geographic data, utilities, planning, zoning, that sort of thing. But some of it is cartography. And so I decided to sketch my bio. It starts near the Great Lakes. I was born in Canada, in the Niagara area. And in '86, I headed off to college in Winnipeg, where I got a music degree. Totally useless. Because unless you're going to get a master's degree, you can't make any money at it. So it was like, what do I do now after graduation? So, but I did, I went to a small Bible college out there, ended up being a bridal college, and I met my wife there. And so we got married and moved to Minnesota, where she's from, in 1990. And those are two little rings, wedding rings there in Minneapolis, Twin Cities. So we spent a number of years there, had some kids. And then in 2008, I got a job down here in Maricopa, city of Maricopa, for the Auction Indian community down there. And I've been working there ever since. And that is also where my love for astronomy really picked up 3 years ago when my family gave me a small tabletop Dobson, 5-inch tabletop Dobson, which I do most of my viewing through. I've since gotten a Maxitov 127 SkyMax, so but I still use this a lot. I bring it to all the outreach. I think it's a great beginner telescope, and it's given me a lot of joy over the years. So why do I sketch? So it is a depiction of what I see. So, you know, you see the Hubble telescope pictures, you see James Webb pictures, and they're fantastic. And I also see all of the imagers, you know, a lot of you are imagers, and they're just really, really great. But when I talk to somebody, you know, what can I see from here? Well, you're going to see a little fuzz, a little faint fuzz, and mostly it's a fuzz for deep sky objects. So that's what you see. And so I decided, you know, I'm going to sketch what I see. My first object that I saw, I got excited. It was Jupiter. It was the moons. It was Saturn was there. This was back in 2023. And I said, I gotta record this somehow. And my phone just takes lousy pictures to the eyepiece. So let me sketch it out. This is my proof. And so it is what I see. And I can come back to it and remember what I was looking at when I saw it, you know, what my feelings, my emotions. And so that's probably the first thing that I think about. It also makes me a better observer. You know, when you look at something for a long time, you start seeing details that you didn't realize were there. And that is true of a lot of different things, not just astronomy. It's true of people's faces, you know, your family's faces. You spend a lot of time looking at them. And you notice details that you didn't see at a quick glance. So, you know, I did the Messier marathon as well, and it's just bing, bang, boom, hit it. Okay, next, next, next. I don't remember what a lot of them were. And if you do the Astronomy League Messier list, they recommend not using the Messier marathon because because you're just hitting them really fast. They want you to observe the objects. And so it makes me a better observer. You start seeing, you know, star trails in the globular cluster. You start seeing, you know, in the galaxies, you know, is this a spiral? Is this a barrel? Is it edge on? You start noticing some of these little things. And so it makes me a better observer. I also feel connected to what I see. So I think back when I'm looking at something, I can think back about what the weather was like when I was out there, or man, the bugs were bad that night, or something like that. Because I've got a documentation of that observation session. Also, it's cheap. It only costs whatever's in your drawers at home with paper and pencil. It's super cheap to start off, and so that's I can't afford all the equipment for astrophotography, so let me sketch it. So these are my very first sketches back in 2023. On the left, there's that sketch of Jupiter. I looked it up. What were the moons? I was so excited I could see moons. Holy cow! And so I sketched out what those moons were, kind of their approximate location, and I thought that's really cool. Right below there is that super little tiny dot with Saturn with a line through it. And wow, I got to see Saturn. I got to see the rings of Saturn. It was not really edge on back in 2023, but with my little 5-inch telescope and the 12 millimeter eyepiece, that's what I saw. So I was excited about that. And then a few weeks later, I saw the Beehive cluster, and with Venus, there was a conjunction. So I'm going, cool. So I did a little circles showing the field stop of the eyepiece, bunch of dots, and Venus. And then a little later, I did the same thing the next night, actually, with a little proper sketch. I saw how Venus moved. And so these are just some of my very first sketches. And then I joined EVAC, and last summer I was out at Picket Post and looking at Stellarium, and I could see, wow, Saturn and Neptune are close by. Can I really see Neptune? So getting the sketch in there, doing the primary stars that were in the field of view, sketched it, came back the next night. I decided, well, let me sketch it again. And then after I did the second sketch, I compared them. I'm going, oh, things have moved. That's real astronomy. That's what they did in the old days. That's what Galileo did. That's what these astronomers did before photography. And I'm going, oh, that's the real deal. I really got excited about that. So I had taken a picture way back in my first few months of the moon, and I had this picture on my phone, and I said, well, let me sketch this. Just check this sketch out. So I decided with a pencil, and I just started smudging around, and I came up with this sketch of the moon that I did back in last year in September. And a few weeks later, I went to the Hyman Ranch, Jerry Hyman's ranch up near Forest Lakes. And so I started doing some deep sky objects. I had a nebula filter, and I started sketching some of those deep sky objects. And so I got the Helix Nebula and the Veil Nebula, and so I was really starting to get into that. And it was up there that I was talking with Brian Teague. Some of you may know. He had his sketch materials, and we were comparing notes and talking about. He had his materials, his pencils, his blending stumps. And I go, wow, you got some really cool gear. I just had pencils and an eraser, and that was it. And so we started talking, and I decided, I could do more with this as well. And so you take these white images, you're sketching what's in reverse. The light parts of what your view is what's dark in the pencil, but you can invert that using GIMP or whatever, Photoshop or whatever, and there you go. You get a more realistic view of the object. And so it was up there that I started getting more interested in sketching as more of a observational hobby. And then Cloudy Nights, they have a massively active sketching forum. If you're not a member of Cloudy Nights, I highly encourage it. This particular forum, because they do post a lot of pictures, I think requires you to register your account so that you can view the pictures. So I think some bots have stolen pictures, and so that's too bad. But this sketching forum is really, really active. There's probably 10 new posts a day of people doing their sketches. And I tell you, it's a huge inspiration for me. And I really hope that some of you check it out. Every month they do a sketching contest. People will post their favorite picture that they sketched over the last 2 months, and you vote on it, and you get bragging rights, but also it's posted on the homepage of Cloudy Nights. So that's a bonus. But man, there's a lot of great sketches. I was looking at some today, earlier today, and I'm going, wow, that is so inspirational. You know, just got me, you know, really stoked again about this hobby and this aspect of the hobby. So I highly encourage you to check it out. You can vote. You can vote on these through the 15th of each month, and check it out. And there's always some great pictures on there, and they're really encouraging. So I post some pictures on occasion on there, and it's just a really encouraging network of astronomers there. So back in October, we did the All Arizona Star Party. Comet Lemon was out, so I sketched that one. That was fun. And then I was inspired by some of these sketchers on Cloudy Nights to start zooming in on the moon and doing some craters. So this is my first sketch of a crater, Chicard crater, with my Maxitov. So 134 times magnification. So I started sketching the crater, and I'm going, wow, this is really cool. You know, to start with the white, the highlight, what the shadow is. You know, you pick something near the Terminator, because that's where those shadows are strongest. The whites pop out, and then the shadows are black. So I use a dark charcoal pencil to do the shadows, and wow, the 3D of these sketches really comes out. And I was amazed at how quickly I just jumped into sketching these craters. So here's Arzachel, Alphonsus, and Ptolemaeus. You know, the three primary ones that everybody knows, the pretty popular ones. I did, this was right at the tip of the Terminator, the tip of the crescent. It was really a cool spot. I'm going, wow, let me just do that. Here we have Archimedes, and you know, none of these are really close to photograph, but they were fun. And you know, these took half hour, 45 minutes at the most. You know, just great relaxing time at the eyepiece, sketching with my little clipboard. This was you know, the 13% illuminated moon. I decided, well, let me sketch the whole thing, and wow, this really turned out nice. I was really pleased with this. And Copernicus and Kepler. I didn't have my. I just had my manual Dobson out there, and so I kept having to move it every 2 minutes. But you know, you do what you have to do. So just started doing some of these other craters. You know, some of them have those prominences in the middle of the crater, the mountains. Some don't. There's a whole lot of variation, and you start looking at those details on the moon, and you're going, wow, that's amazing. You know, what kind of detail you can see on the moon, the ridges, what are they called? The rills, right? The mountains, the rills, the craters, all the craters that you can see inside the craters, with all the shadowing is really, really fantastic. This is probably my favorite moon sketch. You know, so in the Maxitov, no, this is my reflector. So everything's upside down. So south is top, north is bottom. You know, you just start learning where these mare on the moon are. Another one here, 83% illuminated. So the tools are really inexpensive and simple. These are pencils. I've bought some, artist pencils, and at the most, I spent $3 on a pencil. Those be like your Teleview pencils. It's a really expensive pencil. But there's some pastel pencils, white and black. There's some charcoal pencils. I didn't know you could get white charcoal, but you can. You can get a lot of different kinds of pastel pencils. These are not oil pastels. These are dusty pastel pencils. So there's some graphite. I've got some gel pens. So, the little white gel pens, they make great stars, very sharp points of stars, fine tip. And like I said, the most $3 per pencil. Oh, and a nice pencil sharpener. I just grabbed an old compass that my daughter had from high school. So I'll occasionally use that to create a field stop eyepiece view if I feel like it. Mechanical pencil. I've got some other tools. These are some blending tools. So the eraser, a gum eraser, erasing shield, Q-tips. Q-tips make a great blending tool. I've got a blending stump there in the middle, but Q-tips are really great. You can get fine detail to just blend the white pastel or charcoal to create a nice smooth effect. The pocket knife, I scrape some dust off, some dust of the pastel into a little powder pile, and then I use the makeup brush, an old makeup brush, to dab that in there. I'll show the technique later on how that happens. And so there's a little bit of sandpaper if I want to sharpen the pencil tip, cotton balls, so a lot of different blending tools. A little kit, I've got it all there. Those things are over on the table if you want to take a look too. Simple little kit where makes it really handy to take it out to the observing sites, whether it's my backyard or picket post or wherever. There's a lot of different papers. I grabbed what we had at home, but then I ended up buying some artist papers. So the Strathmore, I really like the feel of the Strathmore. It's got some good bite to it that really accepts the charcoal and pastels. So there's Artigan Black. They've got toned, tinted papers. So I want to start doing more with the morning moons or the evening moons when there's still the blue light in the background. So I've got a blue tint paper as well. And just a regular clipboard. I've got that blue tint there. Got a little pad on the bottom where I just do some scratching and getting the pencil tip ready or whatever. Got a red light clipboard so it doesn't bother my night vision. Of course, when you're doing the moon, it doesn't matter anyway, you're having the red light, white light, whatever. But for the dark sky, deep sky objects, I want the red light. So let me click on this. This is a quick little, is this going to work? How do I get this to go? How do I get? Oh, right there. Sorry. It's the pointer. Oh, there we go. All right, there we go. So this is just a quick little sketch. So I've got the crater up in the upper right, showing which crater I'm doing. This was at the on my dining room table with a computer. So this is not at the eyepiece, but this is how I do it. Very simple. Start with the background. Just blend it with a cotton ball. Create this gray background. Doing the light areas that you can see that the sun is shining on it, and then the moon is, you got the shadows, and I'm just going through it again. So it really, it's I tell you, it's simple. And I really hope that some of you give it a whirl because it's easy, it's fun. I can see a lot of errors that I've got with this one, so I'm going to do this one again sometime. But it's nothing that I'm not being tested on it, so it's no problem. Here's an example of the dusting. So you can see when I get it started, you'll see at the top, I've got a pile of white dust, and I've got the knife. I'm scraping it into a little pile. This is the makeup brush, and so this works great for not globular clusters, for nebula, and this is the which one is this? This is the Sombrero Galaxy, M104, and so it's a simple technique, and at the end I'll do some more scraping with the knife and just create little stardust in the top there. Yes, 2 minutes. Okay, 2 minutes. All right, so I'm starting to get into colors. I want to do more of it, so I tried some watercolor background. It doesn't really work. I've got more experimenting to do. Bernard Miller posted this picture on the left of the Whirlpool Galaxy, and I said, no, let me try that. So here's my sketch of that. So these are obviously not from the eyepiece, but I'm just starting to get into some of those other sketches. This is from the neighborhood. This is the conjunction of Venus and Jupiter from last month, with Castor and Pollux up at the top and Mercury at the bottom. So this was a naked eye observation from with South Mountain there from Awatuki. And so I've also been doing a little bit more with landscapes. It's kind of sparked a little bit of interest in the art itself. So I'm having fun with that. So I do post some of my pictures on my Instagram page if you're interested. It's Mr. Spacely _AZ. So go ahead. If you want, go ahead and follow. I'd be happy about that. Anyway, any questions? Thank you. And I'll be available over there afterwards as well. So thanks a lot.
Thank you, John. Got anything hanging in the Louvre or anything like that? Okay, all right. Musée d'Orsay or whatever in Paris. All right, let's see who we've got next here. Dakota couldn't make it tonight, so Kitty, where are you at, Kitty? There we go, Kitty.
No, I don't need the pointer. Okay. How do I start this thing? Okay.
Down here and we'll go to the next slide.
Okay, thank you. Hi, everybody. I'm Kitty. I am the director of the Whimsy Grotto Space Program. And I just want to say, this is my first time using PowerPoint. So all the weird cropping, I tried to fix it, couldn't figure it out. Not everything is cropped weird, but if you see weird cropping, that was PowerPoint's choice, not mine. And everything that I'm going to put up here is all stuff that's made by me, except for a couple of graphs. And then there are 2 rockets that I didn't make. NASA made those. So you'll probably be able to tell which ones I mean. So Whimsy Grotto. If we are going to, let's go ahead and start by thinking of things in the 4-dimensional space-time model way of thinking of things. So 4-dimensional space-time, that's 3 dimensions of space and 1 dimension of time. We've all probably seen these before. That one, the cone one, super useful. Einstein did that, good stuff, very useful. Oh wait, I have cards to help me. Okay. All right, so, right, that's where we were. In the 4-dimensional space-time model of things, that's the one we're in currently, my shop, Whimsy Grotto, is my shop. and it exists online, and it exists at festivals and fairs and expos and pretty much wherever I take it. And that is where I make a lot of art based in science and fantasy and outer space. I really like to do a lot of glow in the dark and neon and UV reactive stuff because it feels like I'm playing with photons, and that's fun to me. So then to talk about Whimsy Grotto outside of four-dimensional space-time, where were we? Yeah. Okay. I'm so confused. Okay, that's fine. I've got this. Okay. First time PowerPoint. So Whimsy Grotto. We're talking about Whimsy Grotto. Before we get to the space program, we're talking about Whimsy Grotto itself. Now, so Whimsy Grotto is a magical place in the using of the word magic as in that it's science so advanced that we can't understand it. So like, you know, if I were to take my cell phone back in time, which you can't do in a four-dimensional space-time reality, if I were to take my cell phone back in time and show it to someone hundreds of years ago, they would say, oh, that's definitely magic. So if I say magic, please know that's what I mean. So Whimsy Grotto is a forest cave oasis that comes into our reality every couple 100,000 years or so. And there's a lot of creatures that live there, the denizens of Whimsy Grotto. Some people say that that's where we got the idea for unicorns and mermaids. I'll leave that up for debate. I'm not going to say one way or the other. But the main denizens of Whimsy Grotto that I want to talk about are these guys. Now, these guys, I can't pronounce their names, so I just call them the beings. And the beings are the ones who bring Whimsy Grotto into our reality. And, well, first of all, who's a little bit familiar with string theory at all? A little bit, just somewhat? Okay, great. So just to give you the quick and dirty on string theory, just so you know what the reason why I'm bringing it up. String theory is a way of understanding the universe. We've got general relativity to explain, and it beautifully explains, perfectly explains everything on the macro scale. And then we've got quantum mechanics that beautifully explains everything on the micro scale, but they don't work together, and it's mostly gravity's fault. And string theory is here to help us make them all make sense, make everything make sense. Yay, we did it. We understand the whole universe. We still have to prove it though. And there's a few different fields of string theory, and in order for them to make sense, we have to exist in not 4 dimensions, but either 10, 11, or 26. I'm not gonna try and explain the math. I'm not as much of a math nerd as I'd like to be. But so the beings come from one of those dimensions that we cannot perceive, and they bring us Whimsy Grotto through their ability to use portals. Now, like I said, portals sounds like magic, but magic is just science that we cannot comprehend. So they bring Whimsy Grotto through portals, and they have tried to explain to us how the portals work. They've drawn us maps, and we can't really make any sense of it. But Whimsy Grotto does provide us with these maps that we can take home and put on our walls. So that's very nice. So the beings want us to be able to travel through the portals. They want us to be able to go to Whimsy Grotto. They want us to travel the galaxy. So they taught us how to make portal keys. And I have a couple of SketchUps of portal keys, and then one that is in our reality right now that's over there. So portal keys can allow you to travel anywhere in the galaxy. Some people have used them to travel outside of the galaxy. They haven't come back. We like to assume that they just liked it a lot where they went, and so they stayed. All right, so where are we now? Oh, good. Okay, now we're at the part where we get to talk about Whimsy Grotto Space Program. Okay, so you might ask, why would they need a space program to build rockets if they travel by portal? The answer is very simple. They think we are adorable. They are like, look at them go with their little machines. Oh, they're trying to go so far out into space. Look at them. I love that. They want to play like we play. So they're like, well, we're going to build rockets too. So they've started building rockets as well. And me being Whimsy Grotto's ambassador to the fourth dimension, I got really excited about it, and I decided to make rockets so that I can host rocket launches to help re-inspire us of our own space efforts through the eyes of the beings of Whimsy Grotto. Whimsy Grotto Space Program. Yes. So now, like I said, the beings, they adore us and our space efforts. However, they have a couple of complaints. You see, it's pretty cool, you know, that we've been able to harness the elements and create the ability to put ourselves into space. That is very cool. But where's the artistry? Where's the design? It's all function, no form. Like, it's like just all these structures that are completely useful, but totally ugly. Like, there's no paint, there's no party, there's no lighting. So that's why I decided to learn how to build rockets so that I can make beautiful things happen. I can do it in the style of Whimsy Grotto. So this is the Zephyr 1. This is the first rocket that the Whimsy Grotto Space Program has launched. Now, as I advance in creating rockets, I'm going to also advance the artistry surrounding it. So my goal is to have much larger rockets with an entire, there's some word that I'm looking for and I can't find it, so I'm just going to gloss over it. So there's going to be an entryway where you use a portal key to get in. There's going to be a museum of all the previous launches and diagrams, and you'll be able to look at the prior rockets and the prior launch pads. There's going to be the Whimsy Grotto shop, gift shop. There's going to be lights and sound, an entire scale model of an actual launch pad, a RC vehicle that's going to bring the rocket in and put it onto the launch pad. There's a DJ, and all this is going to culminate in the launching of the largest, while also being safest, multi-stage rocket that I can manage to pull off. And it's going to have all the bells and whistles, amazing paint job, bubbles, glitter, confetti, colored smoke, parachutes, you name it, everything. And yeah, so that's what's going to happen in the future. So these are the current rockets, and let's see, next thing that's going to happen is oops, wrong way. Nope, wrong way. So for reference, this was the first rocket. It's just an air pressure chamber through some PVC, and you step on it, it goes poof. We had got an apogee of 80 feet with that one, but I think I could have gotten actually higher with that one. I made the body of the rocket just a little too tight, so I might make another model on that design just to prove that I can go higher. But the next stage is to have a pressure chamber with a valve switch, remote electric valve switch. And so that's actually sitting over there. You could take a look at it. This is as far as I've gotten. Don't worry, that box is going to be fabulous when I'm done with it. You're not even going to see the valve housing. It's going to be all decorated and stuff. Oh yeah, I'm going to put like, you got to turn the key, then you got to like open the little cover, and then you can push the button. We're doing the whole thing. Yeah, so I think that's pretty much it. If you would like to follow along as the Whimsy Grotto Space Program grows, we have a Facebook page or a Facebook group where you can join and talk to other people who are interested, and you can find out when I'm going to be having launches, and you can be a part of the party as it becomes more and more of a party. And if you want to follow along Whimsy Grotto, that's where the art that comes out of Whimsy Grotto, it gets posted, and rocket stuff gets posted there too. And if you're just interested in model rocketry at all and want to geek out on it with me and help me learn and build, and we can do that together, just let me know. Any questions? Did that all make sense? That's okay. Thank you, Kitty.
All right, who do you have up this? Tom, where's Tom at? You're up, Tom. Oh no. Like that.
No, I think we'll be all right. Good evening, everyone. I'm Tom Wolf. I've been an EVAC member for, I don't know, I think about 10 years, but I'm not exactly sure. What I want to do is share with you tonight. Well, first of all, before I get started, how many astrophotographers out there? Just quite a few. Oh, good, good. It gives me kind of a sense as to who I'm talking to. But what I'd like to do is just share with you some photographs that I've taken over the years that have something in common. And that is that they were necessitated by being at the right place, at the right time, and with the right equipment. What I'm not going to do is get into a whole lot of technical detailed discussions about imaging and post-processing. We can save that for another day. I want to keep this kind of light. And speaking of light, I was in northern Wisconsin a couple of years ago for a family reunion. And we were very fortunate to see the most beautiful aurora. I mean, this stuff was just covering the sky from the horizon all the way to zenith. And it lasted for 2 full days. This aurora was just going on and on like a 4th of July in slow motion. It's just beautiful. And of course, the sun brings us the aurora. Yes. Oh, I'm sorry. I say the sun brings us the aurora. The sun right now, actually in its 11-year cycle, it reached the peak solar activity about 2 years ago, about the time of that aurora. But there's still a lot to see on the sun. If you have a hydrogen alpha filter or a solar telescope, you can see the prominences, photograph the prominences, solar flares, filaments, sunspots, you name it. It's really exciting, and I think they make very dramatic looking pictures. 2012 was the very first time I had a chance to see an annular eclipse. I've seen many solar eclipses, partial mostly, but to see an annular eclipse was really exciting. My son and I went up to Canyon de Chelly and had a chance to meet a lot of amateur astronomers up there, but we actually recorded the event, and we enjoyed ourselves so much that 5 years later, we decided we'd go up to Utah and see my very first solar eclipse, total solar eclipse. It was only 2 minutes long, But I'll tell you, it was the most eerie, exciting thing I've ever seen. You just got chills up my spine. You know, it was just amazing. You got to try to get one. Try to get to see one if you can. So then, 6 years later, all three of my kids and their families went to Albuquerque with me to see the annular eclipse in 2023. And that was really pretty cool because that was done at the same time as the balloon festival. And our B&B where we stayed at was only a half mile from the balloon festival grounds. So we had two awesome events to see in just one weekend. Wonderful time. Enjoyed it so much that 5 months later, we decided we were all going to go down to Texas and see the total solar eclipse down there. Now that was 4 minutes long. And even though there was a little bit of clouding, especially on the second half of the eclipse period, we did get a good chance to see the eclipse. In fact, on that top image there, you might be able to make out the prominences that were actually coming out from the limb. Very beautiful. And something about these eclipses, taking pictures of family and friends and what's going on around you and their excitement that they're having is really part of capturing the moment. Now, did I do something wrong here? Okay. Just real quick, so that was 4 total eclipses that I saw in 12 years. That's pretty amazing. You don't get a chance to, don't get those opportunities too much. But also the next solar eclipse is going to be in 2045, where it goes across the United States. I mean, there are other eclipses in the world, but in the United States, that's going to be the next one. Now, if anybody is interested in taking up astrophotography, the moon is the best place to start. First of all, it's easy to find, right? It's easy to photograph or focus on, and it really results in some beautiful pictures. You can take pictures of the features on the moon. You can take phases, the lunar eclipses, all sorts of things, and come up with some very impressive photographs and at a very little investment. And it's also pretty tricky. If you want to get zoomed in and take images of individual craters, you're really dealing with atmospheric conditions, and you got to be really careful. It's pretty difficult. And as you can see here, this image down in the lower right, that was not my picture at all. That was just taken off the internet, and it was an example of the crater that I was trying to photograph. And you can see I've got a lot of work to do. Mercury, there was 2 transits of Mercury. They were in 2016 and 2019. Do you see Mercury? You see it on here? That's Mercury. 3,040 miles in diameter. That's less than 1.5 times the diameter of the moon. And then the other picture, the black and white, that's Mercury up close as it's coming across the limb. And that was done with a hydrogen alpha filter. Next transit of Mercury is not going to be until 2032, but that's only 6 years away. So maybe you want to start making plans for it. Transit of Venus was taken in 2012. Actually, the Venus transit was done occurred just about a couple of weeks after that first annular eclipse picture that I showed you earlier. What you see on the right there is just a stacking of images of transit as it's coming into the limb of the moon. It's called the black drop effect. What happens is you can kind of make out how it's kind of like creating a teardrop or a necking kind of a thing before it enters the sun. It's kind of some kind of a phenomenon that has to do with atmospheric blurring and the optics of the telescope. But the transit of Venus now is not going to be available or be around again until 2117. So I'm not going to be around by then. And now we're on the subject of transits. There's a website, International Space Station Transit Finder, ISS Transit Finder. What it does is it shows you exactly where you need to be and exactly when if you want to see see the International Space Station. This is an image of it going across the sun. I got in the car, drove 50 miles out to Sun City West, set up my camera and my telescope, waited a while, turned on an AVI for taking the movie. 90 seconds later, oh, must have caught it. So I put it back all in the car, came home, made this composition. What you see there is International Space Station, went across the surface of the sun in a quarter of a second. Now here's a couple of pictures. This is more of just kind of looking at or comparing different kinds of telescopes and equipment. On the upper left corner is a stacked image of Mars with from a CMOS camera. That's with the Celestron 11-inch in my backyard. The one on the bottom is the same CMOS camera, but it was mounted on the 24-inch Clark telescope at Lowell Observatory. Difference being f10 versus f16.3 on a very large telescope. That really makes a big difference in the resolution of the imaging. I think something else that's probably more distinctive there or more significant is the fact that I think my atmospheric conditions probably weren't the best. The middle picture, do you remember the occultation of Mars in 2022? That one was taken with the C11 in my backyard with a DSLR. The one on the right was taken by my niece, and she's up in the Rockies up in Colorado, elevation over 8,000 feet, mind you. But she's got an 8-inch Dob, and she used an iPhone. So I don't know, maybe I need to get an iPhone. Now, I'm not a big planetary photographer, but you know, after I captured these images, these black spots, those are the Galilean moons that are going across the face. And that really surprised me. And I thought, you know, it really inspired me to want to just take some more pictures of Jupiter and start to learn that. But Jupiter's it's kind of difficult to photograph. There's a lot to it. Maybe if anybody out there that's done it, I'd like to talk to you more about it. Saturn, real quick. To the left is with my C11. To the right, same camera, but at Lowell Observatory. You can see it's a little bit better, or quite a bit better, resolution in that if you can make out the inner ring, that little faint cloudiness, that's the Cassini ring. And the other thing too on this is that Saturn, these two images are about 2 years apart. So you can see how it's been tilting here over the 2-year period. I don't know if you remember the Great Conjunction of 2020. That's when Jupiter and Saturn were 6.5 minutes apart. That's 1/5 the diameter of the moon. That's pretty amazing. And the conjunctions of Saturn and Jupiter happen every 20 years. So in 2040, they're expecting it to be about 2 lunar diameters apart. And in 2060, it's going to be something that's going to look more like this. Anybody ever take a picture of Pluto? No? This was done in 2014. Pluto, that time was pretty close to us, and it was at a magnitude of 11. These were just taken a day apart from each other. But now it's at a magnitude of 14.5, and it's probably not going to be, smaller telescopes will probably not be able to even see it anymore. Comets, and I'm not a comet chaser, but I sure love seeing them when they really show their wares. These are most beautiful when they have both tails are showing, both the ion tail as well as the dust tail. The colored one to the left and the one on top, that was Neowise in 2020. Went out west of town here for that color photo. The one below it is 2015 was Comet Lovejoy. And then the one to the right, is a C2022, but I don't know if it had a name to it at all, other than that designation. Narrowband filters are really nice to have, especially when you're trying to do nebulosity or take pictures of nebulas, and especially in light polluted areas. So what I used here is, and the way I took this is I used a hydrogen alpha filter and used it to capture the light image, basically just like a mono or a black and white. And then I combined that with a stack of short exposures without any filters to get the color, and then bring that in together with them. Another way of doing it is to assign narrow filters for each of the colored channels. Here is the hydrogen alpha, sulfur, and oxygen were assigned to red, green, and blue. And that's how that imaging comes up. Yes? Okay, I'm gonna go real fast. So there's some objects out in the sky that are pretty big. And they're so big, I have to take them in pieces and stitch them together. What you're looking at here is the M45, was a 2-tile mosaic. M31 was a 6-tile mosaic. And it's always nice to be able to test the abilities of what you're doing, you're photographing, kind of take it to the limits, if you will. And what I mean by that is, to the left there is C77. It's a 12 degrees above the horizon at its highest, as seen from Arizona. And C80 is only 10 degrees. So you're really challenged with atmospheric conditions, and even because of that low, it doesn't give you a whole lot of time to photographing. But quite honestly, I don't think these turned out all that bad. Okay, last one. I was reading Sky and Telescope magazine, and there was an article in there about how this Canadian astronomer had discovered a supernova in C11. They call it the fireworks galaxy. I don't know if you can see it here, but where these bars are, I looked at it, and this was back in 2017. I went, I took that picture. And so I went to my files, and I found that picture, but I also found that I took the picture in 2016 also. So it made it really easy for me to compare the two to know exactly what star was the supernova. So if you can see it on here, there's no supernova. And then all of a sudden we got our supernova. And I went another year later, and you can just barely make it to see how much it's been diminished. The fireworks galaxy, real quick, is kind of been known for supernovas. They say that it has, on average, a supernova about every 10 years. So I hope that inspires you. I hope you get your cameras out and put them on your telescopes and take some pictures. Thank you very much.
Okay, I've got 2 more left here. Andrew, you're up next.
Well, good evening, everybody, and thanks for coming by tonight. Back in 2024, after a long, many years of planning and dreaming and working, I took a trip to South Africa to go on safari. You can see here on the map of South Africa is you can see where the Tropic of Capricorn is, and where Johannesburg is, and where the Kruger National Park is. So I flew into Johannesburg, and then I took another plane out to Kruger and stayed at a lodge there. And it's kind of interesting how that works. Well, what I also did was bring the SeeStar with me. Now, this is a smart telescope that will make it very easy to take astrophotographs. You can just plunk it down, calibrate it a little bit, and then get everything on your cell phone. And it comes, those pretty decent pictures can be created from it, and then you can process those to even better pictures. So when I got to the the lodge, this is what it looks like. It has, it's really like a 3-star hotel that is in the middle of the African bush. It has a pool. It has, it has accommodations, and it would be sort of like a Days Inn if you've been to the Days Inn, and at that quality there. And I didn't expect it. I thought it'd be a lot rougher. I thought it would be a lot more, kind of, rustic, where you'd have, a partition in between the rooms. You literally wouldn't have rooms, but it was not like that at all. So here are the lodgings. It's pretty nice for a cabin in the bush, African bush. So, and you can notice there's a bed there. There's a bathroom to the right, and then there's a porch. Now, my plan A was to use the porch as an observatory with the camera. This was to be done, after the safari's over and I've seen all the animals and everything. I'd put the camera up here, and then I'd go inside the cabin and take the pictures. But that did not work. There's a roof there. There's too many trees, too many horizon obstructions. So we go on safari. So we're going to go, here's the white rhinos and the hyenas. The hyenas were actually outside my cabin by the porch, and I could hear them. They made this whooping sound. And when I asked the guide there, Ian, what those were, he goes, "Well, those are hyenas, and these are dangerous animals. They will attack you. They're not just scavengers." And here's the lions. They were always sleeping during the daytime. And here's a picture of a leopard that has a kill in a tree. They take their kills up into the trees, and then you can see the carcass of the antelope there below the leopard there. And here's the Cape buffalo. This is one of my favorite animals. Real badasses, these things. But they were just kind of chill. And the animals really were very calm, and they didn't seem to be interested in people at all. They're kind of like javelinas and coyotes around here, where they just ignore you pretty much. And so we were only about 10 feet away from these animals, and we were in an open car, so that but they didn't really seem to care you were there or really bother with you. They'd look over and, And here's these large groups of elephants that were just everywhere, eating and crashing through the brush. And so they had different shades to them. There were brown ones, there were gray ones, there were dark brown ones, and they all seemed to have different varieties. And this is a puff adder snake, which is similar to the diamondback rattlesnake, except it didn't have a rattle. And that was sunning itself on the driveway to the entrance of the cabin. Well, what does this have to do with astrophotography? Well, I found myself having to ask the lodge personnel if there was some way I could go out at night and take pictures. Now, let me tell you how serious they are about these animals. You're not allowed to walk from the cabin to the lodge restaurant area without an escort in the daytime. Not just at night, but in the daytime, because they're afraid that a leopard is going to see you as a single person and attack you. That's how serious they are about the rules there. So I'm asking them now, why don't we go out at night in the middle of the bush and take pictures? Well, they did it. They accommodated me, and Ian, the guide there, took me out into this clearing, and we spent a couple hours taking pictures. And the thing about southern hemisphere is you can't see the stars, those stars here in the north. And the farther you are down south by the Tropic of Capricorn, you're going to see these great objects that you cannot see here. And they're real classics. And this is one of them called the Jewel Box in Crux. And this is kind of a loosely packed oven cluster, which was kind of like the one in Cancer, the beehive cluster we have here, where it isn't very, it's not very compact. It's sort of like a flock of stars there, and probably a good binocular object. And here's 47 Tucanae, which is a granddaddy of a globular cluster. It is larger than M13, brighter than M13 by far, but not as bright as Omega Centauri, which you can see from here. But this was a real dandy. I was really impressed by that. I didn't expect it to be that bright and that large. And here's the Prawn Nebula, which is kind of neglected by northern observers. But this is an emission nebula in Scorpius. And if you go down to below the equator, Scorpius is way up at the zenith, and it's so much smaller up there. I mean, the horizon, it's spread out there here in Arizona, but it's very small up there when it's very high. And Sagittarius too, the zodiacal constellations. And then here's the Tarantula Nebula, which is in the Large Magellanic Cloud. This was probably the best one I got. And then things like, seeing Orion upside down, where Betelgeuse is where Rigel should be, and Rigel's where Betelgeuse should be. And the belt's in the wrong direction, the sword's up here. So it was really fascinating to see these, see the southern constellations. And there were no incidents with animals, and we were able to get the photography done without, even though we broke every rule they have, we managed to get everything done safely. Any questions? Yeah, I'm sorry. Yeah, just the one night, and it was very clear. It was about as clear, not as much as you'd think, though. It was, transparency was that of, say, the Superior picket posts. If you've been at the picket post, it was about like that, because you have all these communities there. You don't have big cities, but you have all these communities popping up all over the place. No street lights, no street lights.
Thank you, Andrew.
Thank you.
Yeah, if we have one left, and James, where you at? James, there you go. Come on up, James. It should be short. Yeah, just do it. You're all set up, ready to go.
We'll make it short.
Yeah.
So just real quick, I just noticed that I had come back from a trip with a family reunion, and I was packed. Didn't have a lot of room, and I thought, you know what, it'd be nice to have a telescope that I could pack with me for trips that I can compress really small. And so I also am getting a pair of binoculars, and he mentioned this thing called HandyDob 6. And it's a 3D printed telescope, and it all fits except for the mount and this guy here. This whole thing with the eyepieces, everything fits right in here. And with the mount, it's that. So you could take on a plane this whole thing, and you've got the whole setup. So anyway, I just thought I'd mention that to you guys. Here's some specs on it. It's $815. It is available on Amazon, but it sells out regularly, and then they have to restock it. The downside of it, is the optics are sixth wavelength is what they guarantee it for. I think they're better than that. The optics are not bad, but I think it's a little better than that. You can buy a mirror and replace the mirror if you want, and the diagonal, and get better resolution if you want, technically better. But that's almost as expensive as a telescope. So anyway, it's 3D printed. It's all in that container there. You can see the weight of it. It's a carry-on type of thing. The material is made out of a carbon fiber infused 3D printed material, and it's also metal. What's included also is there's a cooling fan to go on the back. I don't have it on there right now. A red dot finder and a built-in bubble level and a truss shroud, which is to cut out light. So that's what it's included. What's not included, or you can upgrade, is the eyepieces. I got some eyepiece set for $115 that are decent. Tripod, that's a ZWO tripod. There's also an accessory they sell. I haven't really had a chance to test it out yet, but it's called push to air. It's basically a push to telescope. It connects Wi-Fi with your Sky Safari, and you can point where you want. It's got accelerators in there. That's $230. And then the optics upgrade. The optics, actually, that mirror that I ordered, I think is more like $500 and something. And then you can get a secondary if you want. But those are completely optional and probably unnecessary. What I found is a lot of the telescope or mirror makers, they guarantee a certain level, but they're actually much better. Matter of fact, the binoculars I'm getting were guaranteed to 1/8 wavelength. And the guy took, he's doing a big order. He got like 100 mirrors, and he took 10 of them, randomly tested them, and they were 9 out of 10 tested at 1/10 of wavelength. So, and this appears pretty good. So it's probably better than what they're guaranteeing. But I'll just get it because I want certified. And then I 3D printed the eye case for, the eyepiece case, 3D printed it so it's convenient. And that fits in there also. And also I had to 3D print an adapter for it to go into the ZWO mount. It's actually a tabletop, generally is what it's used for. That's it. So. Any questions?
How long does it take to set up from the case?
Well, I haven't had a lot of practice with it. The first time took a while, but it takes me about 10 minutes to set up. Breaking it down is a little harder because you got to get it exactly right. So probably about 10, 15 minutes. But if you do it a lot, probably 10 minutes, you can get it done easy.
Oh, Tom had the same question. Any other questions?
Okay, thanks.
Great, thank you, James.
Thank you, James. All right, folks. Well, we are pretty much done. The good news is we don't have to clean anything up, and so we can just pretty much walk out, although I'll be cleaning popcorn off the floor. FYI, I will not be here next month, so Andrea is going to be running the meeting. I am going to go to Europe to watch the eclipse next month, so I'll be out. So anyway, have a good evening. We'll see you.